All right, so I mean, you have a calculator, so might as well use it, right? So the first question, by running each number, root of 108. Let me check and see what that is. Good Lord. Square root of 108. And they say rounding each number in the expression, that's going to be 10 to one significant figure. All right, so the top going to be 10 over 19.72 plus 5.296. Oh, good Lord. 19.72 plus 5.296. Rounding this off to one significant figure, you're going to be 30. And 10 over 30 is approximately 1/3. Now, to one significant figure, this is going to be 0.3. Find the exact value of this. So again, they didn't say using a calculator or otherwise. So we could use a calculator for the inside, but we don't need to, right? 3 and 3, 8 dies. 8 3s are 24, 25, 26, 27. 27 over 8 divided by, and I can do the shortcut to the LCM inside of here. 5 3s are 15. 12 over 36. 27 over 8 divided by 15 and 12 is 27 over 36. 27 over 8 multiplied by 36 over 27. You go with you. 8 goes into this 4 times. Remainder how much? 32, 33, 34, 35, 36. 32. Oh, remainder 4. So 4.5. I remember again that?
Yes, sir.
3 and 3/8 divided by, you could always check it back on the calculator. 5 over 12 plus, good Lord, plus 1 over 3, 4.5. So you got to go for that. Due to the COVID-19 pandemic, the number of available seats in a hall was reduced from 125 to 93. Calculate the percentage decrease in the number of available seats. So it decreased from 125%, let me say by X%. So 125 multiplied by X over 100 is equal to 93. So that's how much it decreased by to get the 93. 125X is equal to 9,300. And X is 9,300 divided by 125. 9,300 divided by 125. The hell? Move my mouse, yes. 77.4%. Now, don't worry, wait. 77.4% is the percentage that will give us the 93. All right. So if I want to know how much the seats were decreased, how much percentage the seats were decreased by, just take it away from 100, we get 25.6%. Look at that.
Yes, sir. And X is equal to 74.4.
No, it will be 25.6% was the percentage decrease. Think about
Yeah,
it.
but and you're working, right?
Yeah.
You put a wrong number from what was on the calculator.
It was 75.4.
74.4.
Oh, okay. 100 minus 74.4. 25.6. Oh, I'll put 74.4 here. Right, but I get this full answer, right? 25.6%. That was the amount it was decreased by. Mika invested a certain amount of money in a bank that pays compounded interest at a rate of 2.5% per annum. At the end of 2 years, the value of investment was that. Calculate the amount of Mika's interests. You could do this one or two ways. You could use the formula, or you could go ahead and do your regular working, right? Now, A is going to be the amount after so much years. So at the end, if you want your interest, you're going to take it away from the initial amount of money that you had to start with. Okay? We could do it both ways if all you want. So let me use the formula first. A is equal to principal is 7564.50 into 1 plus the rate is 2.5 over 100 to the power of 2. 1 plus 2.5 over 100 to the power of 2 squared multiplied by 7564.50. That's how much money she would have gotten after the 2 years. 7947.45. So the interest is going to take away both of them. 7947.45. Take away 7564.50. 7564.50. $382.95. Well, just now. Plug it in as we see it, right? 7479, sorry. 7447.45 minus 7564.5. Yeah, 382.95. All right, Mama Agenda?
Yes, sir.
Good. I mean, come now,
Sir.
fellas. Yo.
And ask for the amount invested.
Yeah.
Calculate the amount Mika invests. Let me read that question. Mika invests a certain amount of money in a bank and pays compound interest at a rate of 2.5% per annum. At the end of 2 years, the value of it. Oh. Right.
So what I was asking for, there was the original principal?
Yeah.
Okay.
Mikai, so you do this one wrong too.
Yeah, I think so, sir.
So principal going to be 1 plus A over that. 1 plus R over 100 to the power of N. 7564.50. 1 plus 2.5 over 100 squared. I will count the denominator first. 1 plus 2.5 over 100 squared and is 7564.5 divided by the answer 7200.
Yes, sir.
You didn't get that, Mackay.
Nah, sir.
Minus your marks one time, right? All right.
Sir.
Yo.
For the first question, I get a different answer than 0.3, you know.
Who you get?
Yeah,
I get 0.4.
I get 0.4 as well.
so I did get 4 first, and I
108
think I get 3.
divided by 19.72 plus 5.296. All right. Now, let me clarify something here, right? By rounding each number in the expression below to one significant figure. So they want you to round off each number to one significant figure.
So I think I take it too literally because well, the top I get the 10, right? And then on the bottom, I had, since it's one significant figure, we get 20 and then plus 5. So 10 and 25, and I get 0.4.
Yeah, I did do that too, sir. And I
Well,
know you do as well.
I guess depending on how you do the question, if you're sure that working, I don't see why they shouldn't give it correct because you did round off each expression to one significant figure. So let me check this back, right? 19.72 plus 5.296, 25. What? Right, and I round this off to one significant figure, so that will be to t. I mean, yeah, I guess if you want to round this off first, you could go ahead. But I mean, everybody would interpret the question a little differently, right? Yeah, CX, you cannot ship it too. So I don't see why they shouldn't give all of the marks. All right, so back to this fella here. X to the power 6. Y to the power 13. Now, ideally, you should have done this, right? X to the power 3 by 2. And y to the power 8 minus 5. It's gonna be y into x minus y. This is a difference of two squares. I hope I'll write down difference of two squares. X minus y into x plus y. Yeah?
Yes, sir.
Hence, okay, hence simplify the expression. So the first one would have factorized to y into x minus y over x minus y into x plus y. Cancel, cancel. Y over x plus y. Yeah? Okay?
Yes, sir.
Yes, sir.
Yes, sir.
The diagram below shows two rectangles, M and N, with their dimensions expressed in terms of x. Given that the difference between the areas of the two is 64, show that x squared minus 2x minus 35 is equal to 0. All right, so let me just get the areas, right? Ideally, boys, I hope distinction time, right? I hope. Tell me if I do that. Area of M is length by width or length by breadth. 3x plus 4 into x minus 3. And area of N, same thing, length by width. X plus 2, x minus 3. The difference between the two areas. So we know that how area of M minus area of N is equal to 64. Now, it would be very, how to put it, boy? Natural to put area of M take away area of N. And this is where the question would have fallen short, right? The difference between their areas. Now, one area could be bigger than the other. And depending on which area is bigger than other, some students might have taken away area of N, take away area of M. And you'll get a completely different answer. I don't know if that is the way to do it, but I mean, if we get through this here, we get through. If we get through, then we will put area of M, take away area of N. So we have, I'm going to expand the brackets one time. I'll have 3x squared plus 4x minus 9x minus 12. Take away, open a bracket, x squared plus 2x minus 3x minus 6. 3x squared plus 4 minus 9 is minus 5. minus 12 or equals to 64. Take away x squared. 2 take away 3 is minus 1. Minus 1 is plus 1. And plus 6 minus 64 is equal to 0. 3x squared minus 5 plus x. Two minus 3 taken away. So now take them away.
Yeah, they take away x squared.
Yeah. Oh, shucks. Phew. Thank you. Right, so that will be 2x squared minus 5 plus 1 is minus 4. Minus 12 plus 6 is minus 6. Minus 6 minus 64 is minus 70. Divide by 2. X squared minus 2x minus 35 is equal to 0. Cool. I'm sure
Yeah,
what I said.
QED at the end.
You didn't say solve x?
No, that's what I just saying that about QED at the end if that would do anything.
Nah, that is more advanced stuff, right? But that's fine. Even if you put QED. Ooh, transformation. The following diagram shows three quadrilaterals PQ and R on a square grid. Q and R are the images of P. Okay. So off the bat, I can see that how from P to Q, that is our enlargement. From P to R, that looking like a combination, or it could be one. All right? It could be one. If it's one, it could be a rotation. It's looking like a rotation, but let me see. On the grid on page 9, draw the quadrilateral P after translation by the vector 10 minus 4. P after the translation 10 minus 4. So going 10 to the right and 4 down. Yeah? Well, I'm doing it right here. 1, 2, all you seen that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 4 down. 1, 2, 3, and 4. So this is this vertex here. So from here, you went up, you went down, and you went down, down 2, down, and you went down. Yeah? Look at that.
Yes, sir.
Yes, sir.
And part 2, reflection in the line y is equal to 0, label this image P double prime. Y is equal to 0 is the x-axis. So we were 1, 2, 3, 4 units away. So it'll be 1, 2, 3, 4 units away. This could be the bottom. The top would be 4, 5, 6, 7. 4, 5, 6, 7 at the top. Bam, bam. Bam, bam. Like that.
Yes, sir.
Yes, sir.
Describe fully a single transformation and maps quadrilateral P onto quadrilateral Q. All right, so one time it's an enlargement with scale factor, correct? Now we had to figure out what the scale factor is and we could measure. We could measure what the scale factor is going to be. Easy one to measure is the line down the middle. All right, because every single dimension will be increased by that scale factor. It makes sense trying to calculate this here and then this here. Use orange. Yeah, it makes sense trying to calculate this here and then this here. Because at the end of the day, every single dimension is increased by that scale factor. So if I check this height here, this height is 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a scale factor of 3. Look at that.
Yes, sir.
Yes, sir.
Nice. Is a rotation, is an enlargement, but the enlargement needs to be about a certain point. to get the center of enlargement, connect a point to its image. So I can connect you to you, and then I could connect you to you, and then bisect the line. When I bisect this line, it's looking like it passing through here. Yeah. When I bisect this line,
So then this is one way to connect the point to the image for all points and where all the line in the circle is where the center of enlargement is.
no, I think, and
And the one to bisect is rotation.
oh yes, the one to bisect is rotation. My bad. Shoot. Right. But even if I write you to you, you to you, you to you, you to you. Nah, this one could be bisect. Because when I connect point to image, nothing I cut in.
So when you extend it, I get to cut that negative
Oh.
10.
Yes, yes, yes. You are correct. You are very correct. So it will be at -9, 7. Alagara? That's my estimate from here, right? Olaga.
I think I get negative 10, 7, something around there. I can't remember.
Let me try it. All right, so the coordinates here is 7, 4 minus 6, 6 minus 8, 6. 7, 4 minus 6, 6 minus 8, 6. And that would have been the top. And then the next one would have been -1, 2. -1, -2, then 2, 4. Then -4, 4. Then -1, 9. Yeah. 7, sorry. -1, 7. Connect home by up here. Right now, I'm doing this because me, I'm gonna waste my time and draw this, right? Line you to you, you to you. Right, all will connect the same spot. -10, 7 by the center of enlargement.
Yes, sir.
Good. Right, so to describe it, Q to Q prime, or P to Q, sorry. P to Q is an enlargement about the point -10, 7 with scale factor, positive or negative? Positive or negative scale factor?
Positive,
Positive. Why?
because the enlargement
No,
is more than 0.
no.
The image and the object on the same side of the center of an enlargement.
That's right. Image and object on the same side of the center of enlargement. All right, Victor? Remember that?
That's right. Never had that. You can repeat that?
All right, so watch this, right? Just to illustrate it for you real quick. If I enlarge this about the point -10, 7, right? Right, we enlarge and dilate this from here, scale factor 3. I'll get what we was talking about before. Yeah? If I dilate this from here with scale factor -3, what we're going up? On the next side. Yeah?
So if it's on the same side of the center enlargement, it'll be a
It'll be a
enlargement.
positive. It'll be a positive scale factor. If it's on the next side, it's going to be a negative scale factor. The only thing that does dictate if it's an enlargement or a reduction. Reduction is fractions, enlargement is just whole numbers. The
Okay.
positive or negatives, they say which side of the center the image is.
All right.
From what I'm seeing here, the image is also inverted. Are you seeing that?
Yeah.
Can't remember that being a property. I'm gonna try something here, right? Let me see, we have a right angle triangle, a point here, and I'm going on -1, right? Let me try dilate u from u -1. Should be on the next side. And it's rotated. Okay. That is interesting though. It's a dilation. So C will go to C prime, D will go to D prime, A will go to A prime, and okay, yeah, it makes sense. It makes a lot of sense. All right, and a single transformation that maps Q onto the quadrilateral R. A single transformation, so that will be a rotation. Yeah? If it's one transformation, it will be a rotation. So, I mean, let me draw it and do it. You could go, or you could go, or you could go, or else could go. We see what coordinates of R is -6 -1, -8 -1, 10 -1. -6 -1, -10 -1. Yeah. Oh, that's nice. -9 -1. Cool. And this will be a rotation. And to check if it's a rotation, connect. Oh Lord. U going to U. U will go to U. U going to U, and U going to U. And we bisect every line. Bam, 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 and bam. You could only do it for just 2 lines alone, eh? Just 2 lines you need to do it. So this is going to be the center of rotation. Then we measure the angle, center to this. Let me do here to here, 90 degrees.
Yes, sir.
Yes, sir.
It is a counterclockwise rotation about the point -4, 2 of 90 degrees.
Yes, sir.
Let's spend time on the saw.
That's I can fly through that.
About the point.
So I did lose some mark here.
Which one?
You know the first part of it where you had to map it on the grid?
Yeah.
Yeah, for the second one, I didn't map P, I mapped P prime onto P double prime.
Oh. Yeah, we'll lose our 2 marks there.
Yeah, so that only mark alone so far.
Easy stuff. Wow. Coordinates of the x-intercept of the line L. No, easy to lose marks here. They just want the x-intercept, right? Some of them might have put L. Where's L? L is this one. Man, what I put 6. Yeah. That is now no, right on the coordinates. That could be 6, 0. And for M, that looking like 0 minus 2. Yeah.
Yes, I get that.
The equation that find the value of k given at the point that lies on the line L. Look up thing, man. When x is 9, y is k. Yeah. X plus, sorry, 9. 9 plus 2k minus 6 is equal to 0. 9 minus 6 is 3. Move the 3 across. 2k is equal to minus 3 and k is minus 3 over 2. Look at that.
Yes, sir.
Yes.
Yes,
Find the
sir.
equation in the line, tra la la la. 2y is minus x plus 6. Y is minus a half x plus 3. I hope all put this. Did you all put this?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Where m is actually minus a half is the gradient. And c is 3 is the y-intercept. Show by calculation the line L and M are perpendicular. Calculate their gradients. Yeah? How much marks is this? Just 2 marks. Let me see. Ooh, fellas. Fellas. Find the equation of the line M in the form y is mx plus c. This is the equation of the line L. Did you all make that mistake as well?
No, sir,
No,
because
sir.
I think I remember trying to find the gradient at M first.
Okay, cool. All you need is a gradient, correct? Yeah? Gradient of M. You could actually draw your graph, vertical distance over horizontal interval if you wanted to. That one easy, real easy. You have a graph. Drop this down here. Drop this across here. Yeah, this will be fine enough. That's gonna be 2 over 1. The gradient of M is 2. Vertical distance over horizontal interval, which is equal to 2. The y-intercept was what? 606. Oh no, sorry. The y-intercept was 0 minus 2. So we have y is equal to mx plus c. Is of the form chalalala. Yeah? We know that how the gradient of L multiplied by the gradient of M supposed to be minus 1 if the product of gradient, I'll look at this. Yeah? You all?
Yes, sir.
And L and M represent a graph of a pair of simultaneous equations. Using the graph, write down the solutions. So the solutions will be where they intersect. 2, 2. Yeah? Correct? Although write it down in coordinate form. Huh? Solution going to be x is equal to 2 and y is equal to 2. That's going to be a solution. Understood? How to do that? Well, look, I remember. The cumulative frequency curve below shows information about the times taken by 200 students to solve a math Olympiad problem. The number of students who took more than 50 minutes to solve the problem. So 50 minutes here. So these are the people who take more than 50 minutes to solve the problem up this side of the curve here. All agree? Yeah? Now, that looking like it going across to 80, 5, 10, 15, 85, 90, 95, 200. What was the scale for this, fellas? 80, 1, 2, 3, 4, 5, 4. Each one go be 4. So 84, 88, 92, 96. So 196 people would have been able to solve the problem in under 50 minutes. Yeah? So 4 students. Look at that.
Yes, sir, I get that.
Yes, sir.
The median time taken to solve the problem. So median is the n plus 1 over 2th value, which is 200 plus 1 over 2, which is 101 over 2, which is 50.5. Yeah? So the median time taken to solve the problem. So 150, well, the 50.5th time is going to be an estimate now. Forty, 44, 48. So the median time going to be approximately 25 minutes. Look at that.
I can't remember.
I can remember.
This one give other problems or? The probability that student chosen at took at most 28 minutes to solve the problem. So at most would be 28 minutes and less. So you want the probability. Well, first I would expect you all to say, let the probability that a student took 28 minutes to solve the problem be X. So you want the probability that X is less than at most. So 28 or less, yeah. Less than or equal to 28. Going to be 28 minutes, 25, 26, 27, 28. You would go up, 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 up. That looking like 64 over 200. Yeah? Look at that.
Yes, sir.
8 over 25, 75. All right, so our easy cumulative frequency curve. complete the table below. We don't even have a need the curve right here, right? We don't need the curve. We have information here. We don't need the curve. Frequency for this is 66. Oh, there's frequency by midpoint. Okay, we need the curve. I thought this was cumulative frequency. For the time interval is 1 to 10. We had 12 people. The time interval was 11 to 20. So how much people fall between 11 and 20? 11 and 20 is here. No, I can see the graph properly, right? So it's looking like 4, 2, 3, 4, 5, 20 people inside of there. Looking like that to me. You could probably cheat the system a little bit. You could have cheated the system a little bit. They just have multiplication. 10. Everything here must add up to how much? 200? $38 people. Now we could still check the curve and see if it makes sure it's 38. One, 6, 9, 1. I wish I can see 41 to 50 student time, right? 41 is over here. The 50 is up here. Well, we know 50 minutes is 196. So 41 minutes is looking like 166, 164. $32. $41 to 50, right?
So I was actually having that same problem, but I didn't know what to do. Is either leave it on the, we'll read it out from the graph, or just calculate with my calculator.
You say using the cumulative frequency curve. Let me check 1 to 10, right? Let me make sure they read off the graph correct, right? 1 to 10. Looking like 1, 2, 3, 4, 3 are 12. All right, good. That one correct. 25, 21 to 30. 21 is here. That would be 40 minus 4 is 30. How much? 36. 30 will be here, and that looking like 80 minus 4 is 76. So looking like 40 people was there. 42. Huh. Well, that's interesting.
So I get through this really easy, but I can't remember how.
So I take all the while on the phone.
Minus, I mean, we reading off the graph. I get 46, they get 40. How much I get? I get 40, they get 42. Where did my two people come from? We didn't make it. All right. Well, let's say we did off the graph. So off the graph, it could be 32. Cool. So put your 32. Since this is read it off the graph, that will change as well. Cool. $32 multiplied by 45. 45.
Yes, and when I add up the frequencies to get the final cumulative frequency, I get 194, right?
Yeah.
So would they still consider that wrong, or did I just error C-sec part?
To me, it looked like a around C-sec part, but are studying, remember when we plotting these things, right, for our cumulative frequency curve, we are going to plot the midpoint and the upper class boundary, correct? No, not the midpoint. We are going to plot the
Cumulative frequency.
cumulative frequency upper class boundary, right? So cumulative frequency and the upper class boundary, and the upper class boundary is usually by the 0.5s, correct?
Yes, sir.
And the time 1 to 10, to be more accurate, we can use the class intervals for our upper class and lower class boundaries, which is minus 0.5 and plus 0.5. Now, if I do that, I most believe from thinking about it, when you're reading off the graph, you'll have to read off the graph using your boundary conditions, your minus 0.5 and your 0.5 when you're reading off and you're counting on the graph.
Excuse me.
Mhm.
So we get 20 for 11 to 20.
We'll do that. Let's put the $11, looking like it's here. Now you can't have half of a student, eh? 20 is here. Again, you can't have half of a student here. Yeah? So we could just round it up. That looking like the 36. And this looking like 16. Because if you're rounding it up, you could round it down too, you know. I rounded it up. I get 36, take away 16, and I get 20. Even if I round it down,
So you'd rather minus it from minus that answer 36. Minus 12 from that.
what we minus and 12 for?
Because it's cumulative frequency, so where you get for the 20 is on a minus from the class below.
One to 10 is this minus this. Then this minus this. Cumulative frequency here is going to be 22. So 22. And the upper class boundary there is going to be 20.5. Understand what you're saying? Cumulative frequency and frequency, right? Cumulative frequency. This and this is supposed to be the same, correct?
Yes, sir.
So if the frequency is 12, the cumulative frequency will also be 12. Then this plus this will give me this one, correct?
Yes, sir.
All right. So if that is the case, this is for my first class interval, which will be a upper class boundary of 10.5, correct? 20.5, let me see what we get for 20.5 from the graph, and that will go in my cumulative frequency column. At 20.5, it's looking like we get 36. Yeah? Again, 36 here. So this 12 plus this will give me 36. So it's looking like what? 24 going here? Yeah? Alert so far. Does that make sense?
Yes, sir.
Fellas?
Yes, sir.
Yes, sir.
Going down the frequency table, 42, 84, 36 plus 42 is, for the next cumulative frequency,
78.
And 78 plus 84 is for the next cumulative frequency. Yeah. Now 162 plus this number here. Well, I mean, given that we get it 24, we could find out that one easy. Correct? First, I had 20. And 32 was the remainder. So I'll just have to add it 4 there. So I have to take away 4 from this here. No, I got 38. So this will be 34. Correct? 12 plus 24 plus 42 plus 84 plus,
So you put 81.
yeah, plus 4. Take away 200. So this will be 34. Yeah, so that will be the correct answer there, boys. 20 and 34.
24 and 34.
24 and 34, sorry. So 24 multiplied by 15.5, 372, and 34 multiplied by 45.5. 1547. Right, so that will be the correct answer there. You all understand that? What you all understand what I do?
Yes,
Yes,
sir.
sir.
Use the information in the completed table to calculate an estimate of the average time taken by the students to solve the problem. That the mean.
Yes, sir.
So the mean is sigma x sigma fx over sigma f. Yeah. Sigma fx over n. So we have to add up this column here. 66 plus 372 plus 1071 plus 2982 plus 1547 plus 222 6260 over 200 31.3. Yeah. Well, sorry. The total length of the running track. Show that the total length of the running track is 350 meters. Two semicircles with diameter L1 and P. Okay, so these are two semicircles that make one circle. So length of the running track. Length of track is equal to the perimeter of the shape, which is 98 plus 98 plus 2 pi r. Yeah. 98 and 98 is 200, 200. 190, 196. 196 plus 2, 22 over 7 multiplied by 49 over 2. 2 cancel with 2, you cancel with you get 7. 196. However, you decided to do it, plus 22 into 7. 350. Nathan walks at a constant rate of 1.4 meters per second. Calculate the time it will take him to walk 7 laps around the track. So 7 laps. Going to be 7 by 350 meters. 2450 meters. And time is equal to distance over speed. 2450 divided by 1.4. 1750 seconds. You could change this to minutes if you want. 29 and 2/3 or 1/6. 1750 divided by 60. 1750 over 60. 1750 over 60. 29 and 1/6 minutes.
So what's the answer for part 1 again?
300.
Alright, thanks.
Soldier Boy runs 1 lap of the track in 68 seconds. Determine the number of laps he have to complete in 1 hour running the same speed. So if you take 68 seconds to run 1 lap. So 1 lap is 68 seconds. 1 over 68 will be 1 second. And an hour is how much seconds?
3600.
1 hour is 3600 seconds. So 3600 seconds going to be 1 over 68 multiplied by 3600. 1 over 68 multiplied by 3600. We get 52 and 16 over 17 or 52.9. Leave it as a fraction now. 52 and 16 over 17 laps. Agora? He's not going to run the 53 laps for sure. All remember again?
Yes, sir.
Nathan completes running 1 lap every 72 seconds. Safari and Nathan start running at the same time. Each completed a number of laps on the track. Calculate the least number of laps that each will complete before they both are at a point L again at the same time. So in order for this to happen, both their distances need to be the same. Yeah?
Yes, yes, sir.
Yeah.
And the part B, right? The first one. They say how much laps he could complete an hour, right? So wouldn't there be 52 laps?
Now, technically, yes. Even if you put 16 over 17 here, you're not going to get it wrong. I cannot give it wrong. All right? Half a lap is a measure, correct?
Yes, sir.
So I will be under the assumption that 16 over 17 laps would also be a measure.
Okay, so if I put the 52.94 and I just put the approximate sign on for 52, I still get mark?
Now when you put the approximate sign and you put 52, I would like it to put a reason why is 52.
Yeah, I put it because completed laps.
Yeah. You go to. All right, so back to part 2. 72 seconds. Each completed a number of laps on the track, right? Calculate the least number of laps that each will complete before they are both at L again at the same time. Alright, but let me start some calculations here, right? So Nathan completes one lap every 72 seconds. Correct? So one lap is 72 seconds. And Tafari one lap will be 68 seconds. So every 1 second, he will complete 1/72. Good Lord. And every 1 second, he's going to complete 1/68. I want to know when both of their distances are the same. I'm just checking the LCM here, right? 1224. Now, I want to make an assumption here, right? How will I do this question?
Put both of the numbers in two different lanes, and I find the LCM. Then
Yeah.
I divide it by the amount of seconds, and I find the laps for each of them. But I didn't put the answer any, like, Safari completes whoever, and Nathan completes that. I
So you
just
get
leave it.
it, you get the LCM to be 1224.
Yeah.
So my assumption would be like Safari complete how much laps Nathan does make? 72. And Nathan does complete 68. Did I see I seen it happen?
I think I get for Tafari. I know he had one more than Nathan, so it's about Tafari get 18 and Nathan get 17.
Yeah, I get it.
Yeah, I guess
Yeah,
I'm
so
close to like
somewhere-
what Victor said.
I'm just checking, all right? Nothing yet there. All right, so the LCM is 1224, right? So divided by 72. Oh, why again 68 for? 17. Because if this man is complete 1 and 17 here. $16 here. Yeah.
So I can't remember exactly what to pay. Looking something like that. So
Yeah, I can do. I will think about this question. I don't know. The wording of this question is a little tricky.
Say it be 1124, not 1224.
This one was for Nathan.
yes, it's
Oh, Tafari go be more. This is 17 here. Tafari will be more. 2, 2, 4, why? More. 68, 18. 18 exact and 17 exact. All right, I will think about it some more. Oh, Jesus. All right, well, I mean, I could put one on one together to see the pattern, right? Okay. It will be the whole top shaded. And then the whole, each square coming down here shaded, right? Oh. Oh.
Nah, so the last one in the top one.
Nah,
is
so-
the-
The last one on the top not shaded?
yeah. I think they put an extra line just to confuse you.
Yeah,
No, I'm talking about this one here. This one here shaded? In the shape?
Yeah.
Looking
no,
shaded.
I'm talking about in the answer, now, so.
Oh.
Yeah.
Oh, let me check and see the dimensions of the thing. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. So this could be 1, 2, 3, 4, 5, 6. And coming down the road here. Right, that will be accepted. Cool. No matter where you start. No matter where you start. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. So this is gonna be is 4 by 4. 5 by 5. 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. Check. All right, the number of colored squares, total number of squares, and the perimeter of the figure follows the patterns below. All right, so we want number of colored squares, perimeter of figure, right, and total number of squares. So for figure 1, 2, 3, and 4. For figure 1, the number of colored squares is 1, 2, 3, 4, 5. For figure 2, it will be 5 plus something. 1, 2, 3, 4, 5 plus 2. For figure 3, it will be 5 plus 2 plus something. 1, 2, 3, 4, 5 plus 1, 2 plus 2. For figure 4, it will be 5 plus 2 plus 2 plus something. 1, 2, 3, 4, 5 plus 1, 2 plus 1, 2 plus 1, 2 plus 2 again. So I can say the pattern here is 5 plus 5 plus 5 plus and 5 plus. This is the number of colored squares. For figure number 1, for figure number 2, it will be 5 plus 2 into n minus 1. 2 into n minus 1, 2 into n minus 1, and 2 into n minus 1. Where n is the figure number. Are you cool with that? Are you seeing that pattern?
Yes, sir.
Because you had already the figure number somewhere inside of here, right? 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. And 3, good. All right, so we figure out the pattern for the number of colored squares. The perimeter of the figure now. Perimeter of the figure looking like 1, 2, 3 by 1, 2, 3. So minus this, the perimeter of figure 1, 2, 3, and 4 gonna be at 3 by 3. Then you're gonna be at 1, 2, 3, 4 by 4. 5 by 5, and then a 6 by 6. Pattern going to be it looking like figure number plus 2 by figure number plus 2. Yeah? Or n plus 2 squared. Correct?
Yes, sir.
Oh, no. Oh, shit. What are you doing, babe? What are you doing, babe? Up in the area. Look at that stop me before I do stupidness, babe. Alright, perimeter is gonna be 1, 2, 3, 4, 4 into 3. 4 into 4, 4 into 5, 4 into 6, 4 into n minus 2. N plus 2. Yeah? And 10 plus 2? Yeah?
Yeah, I look more correct.
A little more correct the end.
Yes, sir. That way.
Huh? Right, so we get the pattern for the perimeter. And the last one, total number of squares. And this one will be the area, which we was just now doing, right? So total number of squares going to be for 1, 2, 3, and 4. First one will be a 3 by 3, then a 4 by 4, then a 5 by 5, then a 6 by 6. And it will be n minus 2 squared. N plus 2. I lie. Yeah. N plus 2 and n plus 2. Cool. Yeah. Yeah. Halo cool dah? Halo cool dah? Hello? For sure.
So I can't remember what I get. So
Right, do some calculations now. For figure number 11, the number of colored squares is going to be 5 plus 2 into 11 minus 1. 5 plus 20, which is 25. Let me verify the perimeter of the figure. Perimeter is going to be 4 into n plus 2, which is 4 into 11 plus 2, which is 4 into 13, which is indeed 52. And the total number of squares is going to be n plus 2 squared. Yep. 11 plus 2 squared. Oh, they give you the pattern here, man. You know how to put the 11 plus 2 squared. That's 13 squared is 169. And and 13 squared is 169 for us.
Yes, sir.
When the number of colored squares is 49. So I have 49 is equal to 5 plus 2n take away 2. 5 minus 2 is 3. Move it across. 46 is 2n and n going to be 23. I mean, this analogous here. Are you seeing it?
Yes, sir.
Perimeter of the figure is going to be 4 into 23 plus 2. 4 into 25, which is 100. And we already have the formulas for n. We make it up already. See how many white squares are in figure 11. So figure 11, we have the total number of colored squares, 25, total number of squares, 169. Take them away, we get 144. Yeah? I'll remember again that.
Yeah.
Hey, we finished section 1 already, boy. What time? 1.5. Not bad. I mean, we could have done a lot of questions. So let me say, out of the 2 hours and 40 minutes, it should have taken probably an hour and 45 minutes to do section 1.
So I finished the whole paper in 2 hours.
2 hours?
Yeah.
That's good. F, G, and H are defined. G of x minus 2. I mean, this is going to just be x minus 2 squared minus 5. You can do the shorthand if you want. X squared minus 4x plus 4 minus 5. X squared minus 4x minus 1. F inverse of 11. All right, let me go and calculate F inverse x then. All what I get, I'm doing shortcut, right? But I expect all it's a really long cut with statements and everything. Let y interchange x and y and so on. Cool. Y plus 1 over 4. So F inverse x gonna be y plus 1 over 4. And F inverse of 11. I'll get 3 for this one here. All remember?
yes, sir. I remember again.
Yes.
H of 1 gonna be 3 to the power 1, which is 3. Which is 3 cubed, which is 27. I'll look at 27 here.
Yes, sir.
All over I draw a quadratic. I don't have to tell Ole what to do for this here. You're going to get 0 here. You will get -2 here. Yeah? Not necessarily. This one, no, not necessarily for the 0 there. -2, you'll get 4. 4 minus 2 minus 2, 4 minus 4. Yeah, you get 0 here. And draw your
Yes.
quadratic as one continuous smooth curve. I'll do the trick, connecting it with straight lines and then tracing it over with a curve.
Yes, sir.
Yeah.
Come on,
Yes,
nice.
sir.
Yes, sir.
A boy. Jeez.
Simple go back up to the previous question. The first part says. Oh, okay. Let's make sure I didn't do the wrong thing now.
Circumference, tangent, circle at U. UW is a diameter. Yes, sir. 3 reasons why the measure at angle Z is 45. There's a right angle here, right? There's a right angle here as well. This angle and this angle are equal. Correct? Now, this angle is a right angle here. Agreed?
Yes, sir.
So because that's a right angle and this is an isosceles triangle, theta is 45 degrees. That is one reason. Yeah? Well, we're talking about angle Z. So we calculate theta, we get theta to be 45 degrees. That is not a reason. We calculate theta. I'll agree with that.
Yeah.
Good. So we calculate theta, rubbing off. We know that how that's a right angle here because the tangent meets the radius at the point of contact at 90 degrees. Yeah? So Z is going to be 90 degrees, take away 45 degrees, and I give them the reason why. At the point of contact, so by so. Yeah?
Yeah.
That is one reason. The next reason, I see in here,
I don't know why.
is 45 here. I seen the angles made by the tangent on a chord is equal to the angles in the alternate segment. Are you seeing that?
Yes, sir.
That's reason 2. The angle at tangent and chord is angle in alternate segment. Wait time, fellas. Just by the way. Earlier, man. Might not have that matter, fellas. Three. Angles in a straight line are up to 180 degrees. I have 90. I have 45. And I add the next 45. All seen that one?
So I had for reason 2, I had that reason 3, and then I had 2 different reasons for the first
What
one.
reason? What other reasons you put?
Reason 1 was the diameter subtends a right angle at the circumference of the circle.
Mhm.
And then from that, I had the base angles and isosceles triangle are equal, and all angles in the triangle sum to 180. And then for the third one, the angle subtended by a chord at
Hold
the
on a
point of
second.
contact.
Hold that thought. Yeah, Naveen, go ahead.
Okay, so the third one was the angle subtended by a chord at the point of contact to a tangent is equal to the angle formed by the chord in the alternate segment.
Okay. Now, how I looking at the question, right? I mean, I probably overshooting the question, but they said that I'll give 3 reasons that explain why the measure of angle Z is 45 degrees. So I will look for 3 reasons why angle Z is 45 degrees. The reason angle Z is 45 is not because UW subtends a right angle to the circumference. That's not a reason angle Z is 45 degrees. The fact that WXU is an isosceles triangle, to me, that is not a reason why Z is 45 degrees. The first reason why Z is 45 degrees is because the radius meets the tangent at the point of contact at 90 degrees. And I do the working to show that Z is 45 degrees. To calculate theta has nothing to do with Z, in my opinion. So I'm looking for all the reasons why Z could be 45 degrees. All right?
Also, I look at it was I solve for Z and I just use the
Yeah,
theorem.
I know how you use the theorems that lead up to calculating Z. Yeah?
Yeah.
Now, I don't know how to go market for this one. I don't know. Could go either way, right? I mean, I can't do much about that one. But you did give solid reasoning, so I don't see why you should lose marks for that. More theorems? Okay. EFG is a tangent, right? Diameter is KF, good. FHK, FHKG on the circumference. By showing each step in the work, where appropriate, find the value of each of the following angles. Angle X is 56. Angles subtended by a chord to the circumference are equal, standing on the same arc. I'll put our reasoning. Fellas?
Upper one just in case, but I don't think it was needed.
Distinctions, right? Angle Y. Nothing parallel. 1, 2, 3. No. 1, 2, 3. 1, 2, 3. Okay. If I have X, or should I put let? If I have X, I have this here. Correct? Is a triangle. All agree with me? If I calculate this here, 180 minus that will give my Y. I'll do that.
Yes.
Oh God, I don't like questions like this as well. All right.
Okay, sir.
Mm-hmm.
We were saying about the previous question.
Leading up to calculating this angle here, where I use this theorem for the diameter, and then I use the fact that this is an isosceles triangle, has no part to play in determining what angle Z is, or giving a reasoning why angle Z is 45 degrees.
Mini next question.
Oh. Which one? This one or the first part?
Yeah, we were saying about it.
Angle subtended from a chord to the circumference of the circle, standing on the same arc, are equal.
That's it?
That's it.
Oh, okay.
So you get X is 56 degrees. What do I get for y? Let me work it out now. That is 19. 19 and 56 is 75. 180 minus 75 is that angle there. So 75 degrees will be angle y. Look at that. I'll remember again. I remember.
So I think I had some similar answers. I can't remember the exact thing, but I know I get 50 something or 70 something.
Vertical post is RT. There is a vertical post RT at R. PQ and R, PQ, R and S are on ground level. Okay, cool. There's a vertical pole at R. Wait here. The angle of elevation of the top of the post T is 21 degrees from Q. So from Q, the angle of elevation to the top of the post T is a right angle here. This will be a right angle here. This angle here is 21 degrees. Find the height of the post. So we'll use trigs. We have the adjacent and the opposite sine. RT over 153. 153 by sine 21. I'll get 54.8. All I remember.
Don't remember.
I remember it.
So I remember doing that though.
QS is 135. Right. Calculate the perimeter of the foundation PQRS. You say QS is 135. We will use the cosine rule to get this length here. Yeah. A squared is B squared plus C squared minus 2B C cosine 29 and the square root of that 74.25 for PS. At the top, for 20.25. I'll remember again that.
Yes, sir.
Ah, boy. How much questions is that on this paper? 10? So wait. No, okay. All right. Explain why QS is not possible. We know for matrices, if I have a 2 by 2, I need to have a 2 by something, right? Row, column, row, column. I'll agree with that. The number of columns in the first matrix must be equal to the number of rows in the second matrix for matrix multiplication to be possible. So the reason this is not possible is the number of rows, no, the number of columns, sorry. The number of columns in Q is not equal to the number of rows in S. State the order of the matrix SR. SR. So S is a 2 by 3. 3 by 2, sorry. So S is a 3 by 2. And R is a 2 by 2. So this here could be correct. And the SR going to be a 3 by 2 matrix. Look at that.
Think so.
Right, two easy answers there. Are you comfortable with the matrices?
Yes, sir.
And the rest all there.
Yes, sir.
Hello,
This was
hello.
Yes,
this
sir.
was an easy question.
E21 and E22, all of this. Calculate E11, first row, first column, first matrix, second matrix. All of that?
Yes, sir.
Yes, sir.
I'd rather go through that with all that, right? Easy, determinant. 4x minus 7 is 5. 4x is 12, and x is 3. Yeah? Big boy here now. All I got trouble with this?
No, not really.
To the last part in this one.
P is the midpoint. R is the midpoint. OR to RP is 1 to 3. OP is 4A. So if OP is 4A, this is A and this is 3A. And OQ is 8B. All right. Okay. PQ. PQ is PO plus OQ. PO is minus OP plus OQ minus 4A plus 8B. PR is minus 3A. RB. RB is RP plus PB. RP plus PB. RP is 3A. And PB is a half. A half PQ. So a half minus 4A plus 8B. 3A minus 2A plus 8B, which is A plus 8B. Come on. Is it? Not
So-
even a little collinear thing, boy.
So the last one. Oh, right. And it's a half of B2, so it will be plus 4B.
Yeah, 4B, my bad. Not even a collinear question, come by. Fellas, if I shut up this exam, I know what to say about all, yeah? If all do get distinctions, I know what to say about all this. Honestly, serious thing, big man thing.
So the only question that no allows marks in is the one that's there that put P prime on P double prime.
The only one that gave me a little bit of trouble was this one here. So 33 marks in this, I might have lost 2 marks.
So one of the other questions, so the same question with the circle theorem.
Or for you? I mean, you should lose marks for that, because you did give valid reasoning as to why you do what you do. But I just interpret the question a bit differently.
Okay, so I might lose like 4 or 5 marks in this for the most
Worst case scenario, right?
worst case scenario, 4 or 5 marks.
And that's fine. And you have your statements.
Yeah.
There's an easy distinction. And it's just paper 1. When is paper 1?
27th, I believe.
27.
A real time, boy. A week. All you doing paper 1s?
So me, I started.
Every day do one now. I
So
have
what?
solutions on the page.
So that might be kind of tough because the real SBA work these days.
I mean, paper one could be lick up for you, right? Questions does repeat a lot. A lot. A lot. A lot. A particular question that repeated. I think we do plenty. Oh, we practice paper ones, fellas. Did we? Yeah, man. This one is a one that does repeat plenty.
So the 27th is our
Friday.
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 so we could have a class the Wednesday or the Tuesday to just do some paper ones.
It could be any night.
Yeah, in the night.
Yeah. I don't mind. We could probably. Well, I have a couple of videos on the page. Not tell there which videos it is. And those are public videos. So and you all know the YouTube channel, right?
Yes.
Right. So videos. Yeah, so I have 20, 22, 21, 20. But I add maths. Shit. That will be from the live, boy. Add maths, paper ones, add maths, add maths. Maths. Add maths. Add maths. Add maths. Add maths. Oh, good lord. All right. I got how to do some videos for some paper ones. I got how to do that before June. I'll do that before June. All right, yeah. So we gonna have some classes for the paper ones, right? And we go work on the most previous years, go back down the road. About 5 years worth is fair to find for me. All right. So if Wednesday we have 2 classes, and Thursday we have our 2 classes, I could probably squeeze in 5 or 6 past papers, paper ones in there. Are you cool with that?
Yes, sir.
All right.
So that really good. So when I went to write that paper too, the